Welcome to ESF Connected. I'm Kate Walker. Today we continue our sustainability series for the Center for Sustainable Materials Management with a further discussion about biodegradable plastics and the exciting groundbreaking research being done here at SUNY ESF. Joining me today is Christopher Thomas. Chris is a PhD student in the chemical engineering department who originally grew up right here in the Syracuse area. His dissertation work focuses on the conversion of Brewers' spent grain to biodegradable plastics, and he has also worked with several student groups here and led startup companies with the same aim. So he'll further explore that today and also after he graduates if we let him. Chris, so glad that you could join us today. Welcome to ESF Connected.
Thanks for having me. I'm super excited to be here.
Yeah, awesome. We're really excited to start this conversation, and I know you brought some slides today to show, but we're really excited to have you here and as part of the research of the ongoing research of the center.
Oh yeah, I've got slides. I've got props.
Ooh.
We got all kinds of things
All
to
right.
get into, like making these biodegradable plastics from brewer stuff. But
Okay.
I think first I would really want to talk about the context of why we're doing this.
Okay.
So I have a presentation outline,
Okay.
and I would like to first talk about, this context of plastic pollution.
Yeah.
This is
Yep.
the impetus for making these biodegradable plastics.
Right.
And,
Yeah.
and how this fits into a circular economy. And we'll talk about what that is later.
Okay.
And then once we have that kind of background set, I think that would be then an appropriate time to start really getting to making these biodegradable plastics from this brewer's waste.
Okay.
So getting into that getting into the process, so the brewer's waste, making the biodegradable plastics, why would I do this?
Why are you doing this?
Yeah. I mean, it's a pretty strange thing. You
Yep.
have this stuff from a brewery, from their mash tank. You have plastics. What connects these things together? And it's actually interesting that we are finding a way to connect them through related issues of waste management.
Okay.
And so that's what ties these two disparate materials together, and that's also a big driver for our research. And we'll take some time to explain why that is.
Okay.
So first, oh yeah, sorry, go ahead.
Oh no, so you're talking about plastic pollution, right? We're seeing it everywhere.
Yeah, exactly. And it's on everyone's minds.
Yeah.
It's becoming increasingly visible. You have governments taking action to deal with it. I don't think you can get plastic bags at the grocery store anymore,
Nope, not
right?
any longer.
Yeah. I think you're seeing your products increasingly labeled in terms of their recycled plastic inclusion or whether or not they're compostable or something like that. And it's also making its way to mainstream media. So I saw this recently. I was super excited to see it. John Oliver is even talking about plastics.
Yeah.
So it's something that's really on everyone's mind. And it's because, in part because we're a very connected world right now. We have all the social media. We're seeing all kinds of pictures from everywhere. And a common picture you see is oceanic plastic waste. And
Okay.
so I'm sure we've all seen some version of this picture. Have you seen that one with the guy in the boat and he's paddling his way
Yeah.
through that
Yeah,
one of those Pacific gyres?
Yes, I've seen that, and I didn't see the John Oliver, but certainly as you reference, governments taking action, here in New York State, we certainly saw, as you referenced, the ban in the single-use plastic bags. There was a little bit of an uptake. I don't know if you saw during COVID. Some of those regulations seem to be relaxed, particularly with single-use plastics,
Right.
and the increase in order to be safe and to protect ourselves in the last year. But certainly, as we kind of refocus and reimagine what New York State will look like, that ban of single-use plastics is critical. So New York State, I know, isn't the only state banning the plastic bags, but I do see it, hopefully in the next couple of years, us going to other products that would be regulated and banned. I know at the statewide level, there's NISAR 3 is doing their single-use plastic campaign and really looking at other items, things like the takeaway containers at restaurants.
Oh, yeah.
And single-use plastic silverware, things like that. So we are seeing an increase in recycling bans or recycling mandates as well, so increasing the use of recycled products. I don't know if we'll probably talk on that a little bit later, so I don't want to get too far ahead of ourselves, but certainly we're seeing it in the regulations. So how is it, have we seen a shift when you're looking at the numbers, Chris? Are we seeing that those regulations are making any difference right now?
Well, so first off, I'm really glad you brought up those points about what else the state is doing to handle plastic waste, what else governments are doing, because I'm really glad to have this conversation with you. I'm sitting in the lab, like I'm trying to make biodegradable plastics, but you're out there connecting, in your position as director of the Center for Sustainable Materials Management, connecting, all these different bodies that are trying to handle it all at once. Like I'm sure you work with NISAR to some degree, or people there, right?
Yep. Yeah. So as I mentioned, I'll just take a sidebar. As I mentioned on the previous 3 shows that we did, the center based here at ESF is fairly new, but the idea is supporting the New York State Department of Environmental Conservation. So they have funded us to really look at the entire hierarchy, which I know we'll talk about a little bit later, but really looking at upstream solutions. And of course, we spent a whole show talking about recycling, so we can't just look at upstream or downstream. We have to be looking across the entire board and figuring out how we come up with sustainable solutions. But a huge piece of that is as legislation potentially is passed at the statewide level, how can we help communities? How can we help municipalities? How can we help the industry and private sector meet these goals? And so we really are serving as a support in that regard.
Oh, okay, yeah. And and I'm sure you're getting more and more support for doing that work too, because of like this increased visibility. Like you don't have to go to an ocean to see plastic waste.
Right.
Just this past weekend, we were trying to set up like a new composting thing in our backyard, and I was like, digging in all my dirt and stuff, and I didn't find a turtle caught in a net, but here's all the plastic waste I found in my tidy city apartment backyard.
Oh my goodness.
Is just and these are things.
This was just in your yard?
Yeah.
Oh
yeah.
my goodness.
And so,
yeah, it's everywhere.
It's everywhere.
So for viewers, you can't see, but really well. But you've got a little cream container here, one of those plastic cream containers. You've got some bubble wrap, which is everywhere. A little, I don't even know what this is, but ketchup container. Yeah, it's everywhere.
Yeah. And I think there's an important theme to recognize about these different types of plastics that you see in here. And that they're all packaging. A lot of them were for single-use packaging. And so when you talk about handling plastic waste issues, you really want to be getting at what is the type of waste that ends up in the environment the most. And it's single-use packaging.
Yeah.
And it makes sense. You use your ketchup and you throw it in the container. Plastic is valued because it's light, but that means it's easily swept up by wind currents, by oceanic currents, and we quickly lose control of it. We'll talk more about that later, but in terms of like losing control of plastic pollution, I have some numbers behind this.
Yeah.
So I think it's important to put this into context. So this is a huge driver of my research. This is a really fantastic article I saw in Science that looks at what the future of plastic pollution will be. And so what they did is they looked at trends for how much plastic waste is making its way into our aquatic ecosystems previous years. And then they modeled what would happen if that just continues. And so on this graph that you're going to be looking at, that's the yellow bar. And if this continues unabated, we're talking about upwards of 90 million tons of plastic pollution entering our aquatic systems every year by 2030. And then it will continue to grow from there, which is super daunting. And so they said, okay, what happens if we hit all our most ambitious goals, like all these government initiatives, all these company initiatives to reduce plastic waste, to mitigate that?
Right.
And that's this like blue and green bar over here. And still, we're talking about a great increase in the amount of plastic entering our aquatic ecosystems every year. And
so quick question.
Yeah.
So that's based on if we were to continue with the mandates as they are now and the regulations that we've put forth, right? Or is that... Current state. Okay, just making sure.
So they were looking at like what happens if nothing, if we just industry
happened.
unabated, and then also even if we get all those mandates. And
they
did show that it has to do with where the mandates are and where they're taking effect. Like you have
Yep.
polluters from other countries which make up disproportionate amounts of pollution. And so that's part of the reason that you see these numbers that you do. Like, we can change what we are doing,
Right.
but that doesn't necessarily mean someone else in another country is going to effectively manage their waste.
Right.
Right.
Understand.
And so this is looking pretty dismal. And so, back in 2010, there was 8 million tons of plastic pollution entering aquatic ecosystems. So like, that was one of the first big measurements. And they said, that was shocking then, but it sounds pretty good right now. And so then they asked, okay, how do we get back to 2010?
Right.
And so this was a big part of their work too. And so in order to get back to 2010, we would either have to reduce the amount of plastic waste we're generating by 85%, or we would have to properly manage almost 100% of all plastic waste.
Right.
And so I want to ask you, I know this is something that you're dealing with in
Yeah.
your position now. Like, how do we handle these kind of goals? Like, how do we approach these kind of goals? What are we doing right now?
Yeah, it's a great question, and it's a complicated one, of course. We could spend an entire 4 shows talking about all of that, but very briefly, when you look at properly managing, right, what we're talking about there is something that's already produced and needs to be taken care of, right? So really we're talking about, as I've said a couple times, downstream, right? So we're looking at, right now, recycling options, which is the best, right? Instead of sending that thing to landfill, which again, actually sending it to landfill is going to be better than letting it out into the ocean.
Right. Yeah.
Right. So at least if someone's throwing away, not throwing it out onto a beach or in their backyard, I guess it's better, a slightly better solution. But recycling, as we have said in a couple of our shows, and recently we just launched the Recycle Right New York campaign, so please check out the website. It's live now. And managing that is certainly a critical piece of the puzzle, but it's not everything. We recognize that even if we recycle to that 99% that you're referencing, we're still not, we're only getting back to numbers that were 10 years ago. But we do need to recycle those plastics that are already produced right now. So that is a critical effort, and we're increasing the outreach and education around that to make it easier for folks, recognizing that in some counties are only going to take number 1 and 2 and certain types of plastics, where others are able to take more of a variety, almost 1 through 6 or 7s, right? So recognizing that there's a lot of education around recycling still to be done, and we need to increase that. So that's one thing that the center is really focused in on,
Okay.
to increase that. But we have to do that in parallel to the other solutions. So you talked about the reduction number as well, which is critical.
Right.
So that reduction number, how do we actually reduce the amount of plastic? Well, there's a couple of solutions. Our favorite, of course, is what we're going to end up with, which is let's create a different type of plastic. We recognize, and we'll talk about the functionability of plastic and why we want to use something like that material, but do we have to use that exact material? Probably not. So we'll talk about that. That's probably the highest and best, is to stop using it in the first place. But if we are, let's redesign the plastics and let's reduce the amount that we're using. And there's a whole campaign around that. I referenced NISAR, but also, there's the education to community members about, using a reusable water bottle and things that we can change in our everyday lives. And then the education that the center will be doing, working directly with our industry partners to say, what can we do on a larger scale? What are the solutions there to make sure that we are reducing the amount of plastic that is being produced, but also just reducing the amount that's in use every day, industry, business, and in our homes, right? So I know we'll talk a lot about those things going forward, but really that upstream piece is where we're going to be focusing a lot in the next 5 years to meet those numbers.
Yeah, and I'm really glad you mentioned an upstream approach, because that upstream approach, that fits into what these authors beckoned for, and that's a fundamental transformation of the plastics economy. That was the suggestion for a solution, because it seems really difficult to recycle and reuse our way out of this issue. And so that upstream approach, that fits in. That's that fundamental transformation right there. And so this brings me to the brewer's waste.
Yep.
So this is part of that upstream solution. Making biodegradable plastic is great, but what are you making it out of?
Yeah.
And so that's why we focused on brewer's waste specifically. And actually, it's kind of fun. When we first started this, no one had really made our type of biodegradable plastic out of brewer's waste before. So we were chasing that goal.
Wow.
Someone else
Okay.
beat us to it, but that's fine. I'm just happy to see it done.
Yeah,
you know?
yeah. I
Yeah.
didn't know anyone had beaten you to it. All right.
Yeah. Yeah, just by hair.
It's gonna happen. It's gonna happen. So,
Yeah.
so how much are we talking about? And I know, there's been an increase, in the interest of like microbreweries and things like that in New York State. But how much waste is out there in terms of brewers' waste? Is that a lot of material?
Right. And so, saying that we're going to make it out of waste, you might be thinking like, is there enough waste to really
Yeah.
handle? Like we make, I don't know, 370 million tons of plastic resin every year. That's a lot.
Yeah.
But brewers' waste alone, there's 81 million tons of that per year that's made.
Wow.
And,
Nationally, is that a national number?
It's an international number.
Okay.
Yeah. But it doesn't have to just be brewer's waste. And that's the nice part about this. Brewer's waste, it's a plant-based material. You can substitute any waste plant-based material into the same process. It could be wheat bran, which there's about 150 million tons of that made per year.
Wow.
It could be rice straw,
Okay.
almost 1 billion tons of that per year made.
Yeah.
And so, there's billions and billions of tons of materials that would be
Yeah.
great to turn into biodegradable plastics.
So what's currently? Do you have any idea what's being done with that waste now?
Typically, there are uses found for it. It wouldn't really be industrially favorable to just trash it. It's
Right.
expensive. It's
Yeah.
called a tipping fee,
Okay.
know. And so they can pay $40 to
People don't wanna
$70
haul it.
per
It's
ton to like
expensive.
haul, organic waste like this to a landfill.
Yeah.
That's
Yeah.
not desirable.
Yeah.
So brewer's waste specifically, this isn't always the case, but often, it's good farm feed.
Oh yeah.
So
I've heard of
farmers will
that.
come pick it
Yeah.
up. This is actually, ours is from Willow Rock Brewery. They have a farmer
Yeah.
who comes, picks it up, takes it to his farm, feeds it to his pigs.
Right.
But
Which isn't terrible. I
You
mean,
know.
I guess he's saving money for his feed.
yeah, he is even, I talked to him. He
Yeah.
even told me, though, it's a race to feed it to his pigs before it goes bad.
Oh, okay. Yeah.
And I'm sure
Yeah.
that this is an issue that
Oh, yeah.
most people find. It's
Yeah.
free, but it's not all getting used. It ferments super
Right.
rapidly.
Oh, okay.
And
Any idea what the window is there? No, I'm curious.
what the window is there?
Yeah, like how long would it be
I
good
think it's
for?
on the
It's
order
probably
of
not
a
that
couple
long.
of days.
Yeah, I would imagine.
Yeah.
Okay, so then you have a real time sensitive transport there.
Right. Yeah.
Okay.
Exactly. And so there's clearly better things it can be used for. And those other materials that I was comparing it to, those are often used. The blanket term is for animal bedding.
Yeah.
It's for litter.
Yeah.
We
Yeah.
can find a better use for it. Like they are finding a use for it, but if we turn it into a valuable material,
Right.
that would be the preferred use.
Yes.
Right.
Of course. Makes sense.
But anyway, backing into the project itself, and so when we're designing these things, we want to keep all this in mind, and linking these issues of waste management together is a tenet of what's called a circular economy. And I'm sure this is something you're already pretty familiar with. It's something I'm learning about as I branch out from the lab.
Yeah.
And so the circular economy, to my knowledge, it's discussed in academic circles. It's becoming increasingly discussed in industrial circles.
Right. Yeah.
And I don't think it brings any really radically new concepts to the table. All it asks for is recycling.
Right.
You recycle just like you recycle plastic bottles right now and aluminum
Yeah.
cans right now.
Yeah.
Those things,
Yeah.
they can be broken down, turned into new cans and
Yeah.
bottles, right?
Well, and yeah, I mean, a lot of this is, and you see the shift happening in industry for sure, where you're designing with the end use in mind, right? So
Right.
it's understanding that to build a circular process within, whether it be an industry or wherever, that you have to understand that entire cycle. So we see it now at the state level, in terms of EPR, or extended producer responsibility.
Super excited about that.
Right.
Yeah.
So that you're thinking about what the end life or what the end of a product may be, and if you're incentivized, right, or if you're a company that if an EPR law is passed, it does move companies to think about, okay, I have the responsibility, and I will incur the costs of that product at the end life. So maybe I can design it differently to not only be better for the environment, but also to save our company and my workers some money, right? And some time even.
Right.
So,
And the way they're designing it to be better for the environment, better for the worker,
Yeah.
It's a shift away from that old school, like, cradle to grave approach, that old school economic, we have an infinite supply of stuff.
Right.
We're going to make our products,
Yeah.
and then we have infinite oceans in third world countries
Right.
to dump it into and forget about it.
right.
We can't forget about it anymore.
Right.
And so the circular economy is also called the cradle to cradle approach,
Okay.
where we are realizing that these materials need to also be broken down. If it's not something that can be mechanically recycled, then it can be biologically recycled,
Yeah.
like a biodegradable plastic, right?
Yeah, and I liked your chart there that you showed. Is the first time I've seen a lot of models of the circular economy, but I liked the circle on the left there, of putting the biological cycle next to a technical cycle like that, and reminding us that we can mimic processes that happen naturally in the environment.
Right. So this is something we want to keep in mind while we're designing our process here.
Yeah.
We would prefer that we capture 100% of our waste and we recycle it. But for those scenarios where we don't, or the scenarios where it's where it escapes in the environment, or the scenarios where it's difficult to do, like it's contaminated by food, it'd be nice to have it go into the biological cycle, where your packaging, your food, it's breaking down, turning back into soil, and being used to grow more plants, to make more barley, to make more spent grains, right? And so really the circular economy, in a sense, is designing to use waste products, recycling, and composting all tied together.
Okay.
So this is one of the things that we're trying to keep in mind while we design our work here. And I would like to also talk about, like, we're not the only ones
Right.
who are doing something about this.
Well, that's good news.
Yeah.
We would. I
Yeah.
mean, it would be a lot of pressure for sure
Yeah.
to be the only person
I mean,
finding a solution.
We were doing it differently.
Yes.
That's like why we're here to
Yeah.
talk about this
Yep.
today. But, so part of that context is talk about what are the other solutions right
Okay.
now.
All right.
And so this is resulting in a huge growth in what is called the bioplastics market.
Okay.
And I think we should take a second to talk about, because this can be confusing for the average person, the difference between bioplastics and biodegradable plastics.
Okay. Yeah. Yeah.
Right?
We had some questions around that, so I'm glad we're going to dive in.
Oh, okay. Yeah,
Yeah.
nice. Yeah. So they both sound nice, right?
Yeah.
But they're not the same thing. A bioplastic is something that has been made from a plant material,
Okay.
but it's not necessarily biodegradable.
Okay.
And so if we zoom into this chart a little bit, so this is a pie chart of our current plastics market. So this tells you our bioplastics market.
Yep.
On the left-hand side, we have the things that are biodegradable. On the right-hand side, we have the things that are not biodegradable.
Okay.
And so these are all bioplastics, but more than half of them will enter our environment and still contribute, choke up our turtles or turn into these things that I have to pick up in my yard.
Right.
Yeah. And we want to avoid that.
Okay.
So it's not good enough to just make a bioplastic. It should be
Right.
biodegradable too, right?
Right. So looking at that chart, for the viewers, the biodegradable accounts for all those the green area
green,
there,
yeah.
right? So we've got starch, we've got PLA, we've got, what is that? PEAT, right?
PBAT and
PBAT
PBS, yeah.
and the PBS. And then that tiny little gold section is other, right?
Right.
So we're not, I can't do the math quickly, but we're at what, 30%, 35% biodegradable? Is that accurate?
I
Or
think
something
that's,
around
that's
there.
good enough
I'm
for
not
these
good at
purposes,
math.
yeah.
So where do we want to be? And how do we get there?
Right. Well, we would ideally be at 100% biodegradable.
Oh, okay.
But that's not going to work for every application. For instance, like a Tupperware, something that needs to be durable, it wouldn't make sense for that to be biodegradable, because that means those things need to last for a pretty long time. You have like plastic piping and stuff like that.
Yeah.
Those need to be completely durable.
Well, I'll just pause and say we don't really need to be used as Tupperware anyway.
Yeah.
There's glass Pyrex with I might need a plastic lid, but there's no reason why we need to have the Tupperware.
Right.
Just as a side note.
But with like
But
single
it's a
use.
good example. And I think you referenced a couple of other things, when we look at industry and we look at items that certainly can't be
Right.
substituted out.
Right. I mean, like, I can't think of anything in this bag
Right.
that needs to last forever.
No.
Right? Like, does a ketchup packet need to last forever? Does the packaging for your one-day shipping from Amazon, does that need to last forever?
Yeah.
Probably not.
Yeah.
And that accounts for about 40 to 60% of the entire market is packaging.
Right.
So ideally, at least that should be 100% biodegradable.
Okay.
And we can get into different definitions of what is biodegradable. another time.
Okay.
Because there's
We'll save
so many
another
different,
show for
yeah, there's so many different definitions of that. So this is one of the things that we're keeping in mind, right?
Okay.
That it's not just a bioplastic, it's a biodegradable bioplastic. And, you know, to go back to that pie chart, if you can bring it up, thank you, yeah. So the green side is looking good right now.
Yep.
Because we're like, good, it's biodegradable, so we're good there, right?
Yep.
Well, not necessarily, because a good portion of that green side, those plastics are made from agricultural crops, you know, soybean oil, canola oil, and the like. And that brings a whole host of other issues. So we're making this biodegradable plastic, but you're farming food to make the plastic. And
Yeah.
you know, I have friends who do lots of research on, for instance, you know, algal blooms in lakes. And that's because there's all kinds of like farming runoff that enters the lakes, causes this environmental havoc. So,
Right.
you know, what we're getting at is that that green side, that's burden shifting.
Right.
That's, you know, we're getting a biodegradable plastic, but at what cost?
Right.
What,
And so you're creating a virgin material basically instead of something like, say, a waste that was going to go to the landfill.
Right.
And that is also energy intensive in the creation of
exactly.
of the material.
Exactly.
And has its own impacts.
Yeah, yeah. So like,
Okay.
you know,
Yeah.
So this is another aspect of our solution that we're keeping in mind, that it needs to be biodegradable. It needs to be sourced from something that's not, you know, an agricultural crop. And then there's another aspect of it too. So you have your biodegradable material, your compostable material, if you will. But where does it go after that? And so what I pulled up now is a map of composting facilities in the U.S. And take a look at this. You'll see it's mostly red and yellow dots.
Okay.
And so the red dots, the yellow dots, those are places that are not going to take your compostable cup and your compostable plate. And the green ones will, but they're kind of hard to see. They're pretty well obscured by...
So even if we're increasing the biodegradable bioplastics, if we're putting them in the garbage or putting them in our recycling, we're not taking care of them properly, correct?
Right, yeah, yeah, exactly.
Only if they were to go to those green dots on that map.
Only if
It's-
they're to go to
right,
the green
right.
dots.
Okay.
Right, and so we want more green dots. And how do we get more green dots? How do we get more composting facilities to take these biodegradable plastics?
Right. Well, we'd have to increase the use of them, I would assume.
That's probably one solution, yeah. And I, you know, from my end, from the research end,
Yep.
the other one is to ask them, okay, why weren't you taking it?
Right.
You know, so you talk to these composters, and they will tell you because they have a 60 to 90 day turnaround time.
Right.
You know, they want to have their stuff, their food waste, turn
Finished.
into soil within a couple months. And those, you know, specifically like PLA forks and things, those will still be there. And that's a problem. So you need something that's more biodegradable. And,
Okay.
you know, we'll just zoom in on this. So, you know, you're getting these compostable plastics, you're getting these biodegradable products, but you need a place for them to go to. They need to
Yes.
fit into a good infrastructure.
Yep.
And so this is the other aspect that we're
Right.
keeping in mind when we develop our solution here at ESF.
So, just to clarify, if the product that you were making had that 60 to 90 day biodegradability and could break down that quickly, there is no reason why any of those dots on that map couldn't take that product, correct?
Right, yeah. And, you know, those do exist, but because there are ones that don't do that,
Right.
they kind of just say, no,
Right.
no plates, no cups.
Right.
We
it's
don't
too
want to run into
confusing.
Yeah, it's too confusing. We don't
and,
want to.
and on their end, it is complex, and they'd have to look into, right? So let's
Right.
make it easier for them.
Right. And so, you know, now now we can get into the technical details, but
Okay.
I think it's important to show where these technical solutions are being applied.
Okay.
You know, so we're trying to solve an issue with plastic pollution. We're trying to make sure that these plastics are made in a way that they're actually biodegradable, that they're not going to be using agricultural sources to be made, you know, and that they will be accepted by a composter later.
Right. Yeah.
And so to get into that technical stuff, this is probably a little bit more fun for you guys, at least, you know, because this is where we can start talking about my props.
Yeah.
So in the simplified version of things, we make sugar and we feed it to bacteria.
Right.
And those bacteria make plastic.
Right.
It's pretty easy. And so I have some of the stuff we've been using.
wow.
So here's some Brewers
Oh,
spent grains.
Awesome.
If you want
Thanks
to
for
check
bringing
that
this.
out. Yeah.
Okay.
And so that's what we start with. And
Can I
while you're
open
taking a
it?
look at that, yeah, please, feel free. It's
Awesome.
food grade.
Yeah.
So this research is not only interesting because of the way it can be applied later, but also because of the way it came about.
Okay.
So this is like a cross-campus collaboration, right? So I'm from the chemical engineering department.
Yep.
So we have specialties there. My advisors, Dr. Kumar, Dr. Ramarao, their collective specialty is taking plant-based, taking agriculture materials, food wastes, turning them into bioproducts.
Okay.
And I had my friend, my roommate, Dr. Ryan Scheel, who his lab with Dr. Nomura specialized in making biodegradable plastics.
Okay.
And, asked him what they were making it from at the time. Like, it doesn't matter. We're just trying to find cool ways to make them. And I'm like, well, let's connect our stuff,
Right.
like, let me let's make your plastics out of our waste materials.
Right. Yeah.
Because that would be like an impactful form of research to do.
Yeah.
And so we got together and,
And what's the time frame for that? Was that a while ago or?
So our collaboration with them, I mean, there have been other similar collaborations on campus before this. Dr. Ramarao was already involved with one
Right.
with Dr. James Nakis. I think you talked about that
Yeah,
last
he
time.
did, yeah.
But this specific one began December of 2019.
Okay.
Before then, I had a totally different project that I didn't think was fun at all. I'm super late in my PhD, so maybe it was crazy of me to do this, but
Yeah.
I think it's better to do something you're passionate about,
Yeah. It's exciting.
And, I had worked with startup companies and doing this stuff before, so, this was what I wanted to do.
Yeah.
And I'm glad we did it because we had some important discoveries, which we'll talk about in a second.
Okay.
Um,
Right.
So we get these brewer
Yep.
spent grains, we take them,
And so
as-
you're getting them, do you have a couple local suppliers that you're using right now? Or who are you getting this from
I mean,
now?
I got these from the Willow Rock Brewery, which
Okay.
is, just down the road.
Yeah.
Um,
I haven't gone there yet, but I'll put it on the list.
yeah, definitely. I mean, they're super nice about it,
Okay.
Rockney Roberts over there has been very cordial and helping us do this work.
Okay.
Yeah.
Yeah.
Um,
So you're getting it there for now.
yeah, so we get there, they've taken their starchy sugars that are good for making beer out of it already.
Right.
And all we do, there's a bunch of fibrous sugars that are left over,
Okay.
and we break them down.
Okay.
And we break those
So
down.
you're taking this, you start with this, and then you're breaking that down.
Right, yep. And we break that down, and we make this.
Oh, wow.
And we just make sugar water out of it.
Okay.
It's nothing crazy.
Yeah.
I mean, we can get a lot of technicalities
Yeah.
about the different ways to do that, which are super important in terms of like process economics and sustainability.
Right.
But we're taking that, we're making sugar water.
Yeah. I mean, you're going to want to make sure that you're doing that efficiently and in a sustainable way, is what you're saying. Like, there's
Yeah.
a lot of details around
Right. And
how
so,
you get to this from this.
exactly. So that's a huge area
Yep.
of our research that Dr. Kumar and Dr. Ramar are working on right
Okay.
now. It's very important how we get this sugar water.
Yes.
But we get that sugar water, and then we feed it to recombinant E. coli bacteria. And so this is what Dr. Nomura had developed before, and then
Okay.
we worked with Dr. Ryan Scheel to
Okay.
implement with our process.
The bugs.
The bugs. Yeah. I don't know. It's up right now.
So
yeah.
there-
So
yes.
there
So
it is
that's
right there.
cool,
There's
yeah.
ours. That's
Okay.
actually a picture we take from our bacteria. I like this one because it looked like a dog paw.
Yeah, it does.
Yeah. The little toe beans.
Yep.
Yeah.
Okay. So that's a picture of the current bug. that you're
Right,
using.
yeah. And so what we did initially was we took it and we made like the standard form of our biodegradable plastic. So we make what is called a polyhydroxyalkanoate. It's a mouthful. We call it
Okay.
PHA.
Say it 4 times fast.
Yeah, actually, I
you don't
can't.
have to.
That's hard. Yeah, and so we call
Oh,
it
you brought some.
PHA for short. And I brought
Okay.
some, yeah.
Okay.
And so we made this, the industry standard first. You saw it in that chart earlier, 2.5% of plastics are this right now.
Okay.
It has some uses, but we've kind of improved upon that too. So I'm going to pass this to you.
Okay.
This is plastic that we've made from that spent grains right there.
Okay.
And, there's a reason that like this isn't a huge thing on the market right now. So what I'm going to ask you to do is like, go ahead and pull on that. Make sure the camera can get this. I want you to pull on it and rip it.
Rip it?
Yeah.
Yeah.
So you see how it kind of just snapped?
Yeah.
It broke?
Yep.
It's brittle.
Yeah, it's super brittle.
That's a problem.
Yeah.
It limits the amount of applications you can have for it. Because if you take like a plastic bag like we used to get, this
Yeah.
one actually, like, I was getting out of my car and it blew up to me on my way here. It was super. I was like, I guess you're coming
Like,
to
I
the show.
guess-
Okay.
It was meant to be.
Yeah, so you saw how,
Yeah, it's breaks
Kate
very
pulled on
easily.
that, it broke, it was like super brittle. You pull on this, it stretches,
Yeah.
it's elastic, it's still strong even after you stretch it.
Yeah.
So these are the kind of materials that material properties that you'll get you widespread application. And so what we started with can be used for a few things, but we want something better because we're tackling a global problem. And so we figured out a way to get that better solution.
Ooh.
And so we take these E. coli, we make not just polyhydroxyalkanoate, not just the PHA, but we're making specific copolymers.
Okay.
So along the way, we kind of made a couple connections. They were there.
Yeah.
Just a few different things had to be connected. Bringing some people who are used to waste processing into the world of making these plastics, having world-class PHA, researchers here at ESF,
Wow.
which I wasn't aware of until I started looking into it.
Yeah.
So
That
we
must
had.
have been exciting knowing that they were just right down the street. right.
Yeah, I
right
mean,
down a couple of
I first
doors.
talked to them. They're
Yeah.
like, we make PHAs. I was like, that's cool. And
Yeah.
I started working with them and researching it. I'm like, oh no, you can do things that like nobody else can. Oh wow,
And they're right here.
aren't we
Great.
lucky? Yeah.
Yeah.
And so what we have though is an answer to this problem. So that's brittle. It's not working out super great for replacing plastic bags, for instance. But we have developed this way to make copolymers too. And I won't get into the details of it because it would be kind of confusing to do right now with this
Yeah.
format.
Yeah.
But essentially, for a long time, people were making one or two types of PHA.
Right.
There's many different kinds you can make.
Okay.
And we have kind of now unlocked a way to make millions of different types.
Wow.
And we can make specifically whatever we want, whatever different ratios. And so this is kind of like an exciting door to open because the possibilities are endless.
Okay.
Yeah. And so that's why we're here today, because we're looking at this plastic problem, we're looking at the current solutions, we're seeing the shortcomings, and suddenly it's like, this might be it.
Yeah.
You
And
know?
we can utilize this waste stream, which isn't waste, right? It's a resource, and that there's so much of it out there, and take that and create this new product. This is very exciting. So where are you at now with your process?
Right. So we're patenting it, so I
Okay.
can't talk about it in detail.
Oh, when can you talk about it?
Actually, within a couple months. And
Okay,
I really
great.
look forward to coming back then
Yeah.
to,
Yeah, we'd love to hear more about
to
it.
do another one on
Yeah.
this.
Yeah.
Yeah, and so at this point, I guess we'll just open up to questions.
Okay,
Yeah.
great. Yeah. So a couple questions, and just for the audience and for those that are chiming in on YouTube, you can post your questions in the chat box, and I can ask Chris directly. But I know we had a couple questions last time around these plastics, and I think you answered them here. But let's just reiterate.
Yeah.
Aren't they just going to end up in landfill? And I think and aren't these just as bad as plastic, right? Bioplastic. I think you cleared that up, but do you want to just kind of clarify that for the
Right.
viewers?
So I think, yeah, I remember that question. So I
Yeah.
think their concern was this was probably someone who's pretty smart about plastics, and they
Yeah.
knew that like PLA, which is a super common one right now, that's actually a synthetic polymer.
Yeah.
It's not
Right.
natural.
Yeah.
So even though it's compostable, it persists for a lot longer than
Yeah.
like this PHA, for example.
Yeah.
So, PLA may take 30 years to actually break down,
Right.
but this would be much faster than that.
Right. So the PLA that's being sold right now as a bioplastic in the grocery stores still takes 30 years to break down.
I mean, if you were to just like throw it outside,
Right.
so that PLA is designed to
Right.
go into a high temperature
right.
composting system.
Got it.
So if it goes there, that's fine.
It's, yeah. And then the process is usually what, a year, 6 months, 18 for breaking it down. Do you know?
Oh, I don't know that offhand. Probably
Yeah.
much shorter than that because
Yeah.
I think composting facilities have pretty quick turnaround time,
Yeah,
so
yeah.
they can be profitable.
Yeah.
I would imagine within at least a couple months.
Okay.
Yeah.
So another just question that popped in my head is to talk, and I know you're not an economist, but thinking about the economics, and I know part of this project you are looking at the economy and the economics of developing a product like this. But one of the things that we recognize for alternative solutions a lot when we talk about sustainability and we talk about solutions, we want these solutions to be accessible and implementable
Right.
for everybody. And often cost can be an issue. I know that when I go to look for a more sustainable, less toxic mattress or
Right.
products for my kids or whatever it may be, often the safer, better, more sustainably designed product is one that is much more expensive.
You have to pay a
So
premium
can you
for it. Yeah.
speak a little bit to, I know, this isn't where your research is, but can you speak a little bit to that?
Right. Yeah. I mean, so this is something I definitely considered through my research because what's the point of doing something that won't be economically adopted?
Yeah.
Right? You can't force people to take stuff. They have to buy it eventually.
Right,
You know,
right.
whether it's the consumer or the industry that's doing it.
Yeah.
And so that's a distinct advantage we have with using a waste material, using waste material. So not only is it economically sound, but your also raw materials can be like 20% of the cost.
Right.
And so these are things that should be pretty low cost because they're waste, and
Yeah.
the competing uses like
Yeah.
animal litter.
Right.
Or sometimes they're negative cost if you're
Right.
talking about a facility that has to like send their stuff to a
Yeah.
landfill. So
Right.
like,
So a negative cost, meaning you could potentially be saving somebody money, correct?
right, yeah. So, to get into the prices
Yeah.
of what it would be specifically, that's hard to do at this point. Actually,
course.
Dr. Kumar is
Yeah.
spearheading a techno-economic analysis of
Okay.
the entire process.
Yep.
So we can get those numbers. And
Yep.
so we can identify points in the research, the
Mm-hmm.
bottlenecks where the cost is constrained, and then we
Yeah.
can focus our research there and make sure we're attacking those problems properly.
That's really exciting.
Yeah.
Yeah, that's really exciting. Awesome. And I'll just make a point because I didn't reiterate or I didn't mention this earlier, and now seems to be a good time. When looking at the research that is being done, I do want to also talk very briefly. We at the center, I referenced a couple of times the research that's being done here on campus, and of course now you and Ram have come on to the show. We'll talk a little bit at some point with Doug Daly is going to come on and talk about the composting piece.
Yeah.
As well. But we also have 3 other university partners that we are working with.
Okay.
And Alfred University has expertise in glass. SUNY Stony Brook is going to be doing some waste characterization studies and looking at some of the economics as well. But UB has really been working a lot on plastics recycling and plastics. So as I referenced earlier in the show, really understanding the recycling piece of this is going to be critical and increasing recycling. But UB's research is really exciting in that they're looking at all of the other pieces as well. So looking at, increasing infrastructure, making sure that the plastics are being, cleaned properly, and that we can reduce a lot of the issues with recycling is that plastics get dirty in the process. They have food in them, and
Right.
therefore they get landfilled because of contamination. So we'll be looking a lot at infrastructure for recycling, but really then at that other piece, when we reference at the top of this hierarchy and we talk about upstream, again, looking at increasing the use of recycled materials and increasing the recycled plastics. So that'll be I wanted to make note before we went off of the show that this is a huge part of research as well, is not just here at SUNY ESF, but also with our industry partners or our academic partners. So I'm sure some of that research that'll come out will be interesting to you as well.
Yeah, definitely.
As we look at, and that last piece is looking at and understanding the economic market. So how do we expand the market, and how do we support entrepreneurs like yourself that are coming out with solutions like this? So I know, real quick, I guess I have a question for you, Chris. We'll have a couple questions too from the audience.
Okay.
But the question is, okay, where do you go from here? How do we keep you here at SUNY SF? But what are some ideas for taking this kind of next steps for you in the next year or 6 months?
Right. And so I just want to back up a second. I think it's super important that you mention these other arms of the project because this is a cool product, but there is going to be no golden bullet to handle
Right.
all. It's a complex issue, right?
Yep.
And so this is going to fit into all types of systemic changes. But for my portion of it, how can people help us handle, and improve this research?
Yeah.
Well, I talked about we're going to be able to make who knows how many different kinds of plastics, right? And
Right,
so a
yeah.
simple thing would be
Yeah.
like, for anybody watching, like, just tell us what type of plastic you want.
There you go.
What do you
Ooh,
want a
yeah.
plastic to do?
Put in the chat, what kind of plastic do you want?
if you're a user,
Yeah.
Do you want that plastic? Does that plastic have to be
Yeah.
cheaper?
Yeah.
Are you willing to pay a little bit more? Like, that's super useful information to know.
Yeah.
If you're, someone who is more involved at an industry level, what type of properties do you want to see? Like, how stretchy do you want it to be?
Yeah. Yeah.
So anything, honestly, because
Okay.
at this point, we're just going to be kind of not shooting in the dark, but we have a lot to
Guessing.
sift through.
Yeah.
And
Yeah.
so, anything that we hit, it would be nice to know
Yeah.
what works out for
Yeah.
everybody else.
Right. And that through the center is some of the information that, with our industry partners, utilizing the university networks that we have for research, reaching out to the industry and saying, what do you need? What is
Right.
what is kind of the prioritization in terms of, what are you using most, and how can we help? Really, we do have a question here, so I want to make sure we have time for that.
Yeah.
Angie Alberto has an awesome question here. Do you think, and I'll have you answer it first, and then
Okay.
I'll answer it, okay? Too.
Yeah.
I wanna chime in. Do you think the uptake of bioplastics, and I think she's talking about biodegradable bioplastics
Okay.
here, would be best implemented through policy and government enforcement, or targeting specific markets/buyers like a Walmart or commercial industries?
My understanding, and it's super nascent, obviously I'm just kind of learning about this stuff, I think it's both. So you want to be developing a product that the market
Yeah.
is naturally going to want to uptake,
Yeah.
but at the same time, there's a great amount of education that needs to be done because that market depends
Yeah.
on consumer demand.
Yep.
And that's kind of where the role of like the government and other
Yeah.
entities would come
Yeah.
in, right?
Yeah.
And so you want to design something that corporations want to buy, but they're only going to want to buy something that consumers are demanding, and that's
Right.
where the government can kind of come in and
Right.
influence and say,
Right.
hey, this is the difference between a bioplastic and a biodegradable
Right.
plastic.
Yep.
That'd be good to know.
Yeah.
I mean,
yeah.
I'd love to hear what you have to say
Yeah,
too.
I say the same thing. I just say it a little bit different, which is both is the quick answer.
Yeah.
But we know for anyone that has worked in government or created policies, they're only as good as the data that inform them, right? So
Right.
in order to create legislation that is going to be effective and beneficial to everybody, meaning economically, socially, environmentally, we need to make sure that we're coming up with solutions at the legislative level, at the state and federal level, that are informed by what the actual needs are for our industry partners and for the folks that are going to be actually doing this. So working with buyers, working within the market, and to understand, back to your point, what folks' needs are. We know that the answers and the solutions have to be cost competitive or at least neutral in order to implement.
Right.
So thinking about that, but also, what the market will support and then where we want the market to go, right? So I would say awesome question, Angie, and the answer is
Yeah.
certainly these things have to work together. They have to work in parallel. And to come back to the center, that's really why the state has invested in ESF and these other academic partners, is to provide the data and the analysis to understand where the gaps are, and then to help inform those in the position to make legislation and to make policy that makes sense. So really that's where we're at. Thank you very much for that question, Angie. I know we've only got a little bit of time left, and I wanted to loop back to something that you said right before the show. That's just an interest to me personally, as someone that has worked kind of in pollution prevention and talking about toxics a lot. You mentioned something about some beads that you had, or about production,
yeah.
and making sure that you were being sensitive to, when creating materials in the lab, that you were doing so safely and trying. And you mentioned chemical. What did you say? Chemical green chemistry.
Green
I think
chemistry.
you referenced.
Yeah,
So
exactly.
having a tiny little background in green chemistry, I'm not a chemist. But can you just talk for 1 or 2 minutes? Just what were you saying about that?
So I mentioned that we need to use green chemistry to make this.
Yes.
But we also need to use green chemistry to make that.
Okay.
And so, full disclosure, I made that using horrible noxious chemicals.
Okay.
But, that wouldn't be the industrial way we would do it. And so we're already exploring that too.
Yeah.
And so I have a couple samples of some like little pellets that I've made.
Okay.
And so we've made this using, I don't know if you guys can see this at all.
Yeah, they can see it.
Green chemistry, using just surfactants,
Yeah.
and heat,
Okay.
like super easy,
Yeah.
it's nothing crazy. And we want to make sure that like not only are they cheap, whatever you're using to do this, but that you're not going to deal with some, poisonous fumes or something like
As a
that when you're,
result. Right. Yeah.
because we're attempting to come up with a solution to a
Yeah.
global problem. And
Right.
so even if it has a minor environmental impact, that's going to be magnified greatly.
Right.
And so we want to make sure the chemistry we're using is something that's relatively benign.
Yeah.
And so we're developing that side of it too.
Great. It's so
Yeah.
exciting to
Yeah,
hear
I don't know
that.
if you want to.
Yeah, that's
You
cool.
can-
I'll
you
look
can
it up.
play with
It's
them
great
too,
to hear that some
Yeah.
green chemistry principles are being utilized here, and recognizing that when we look at industry, they're wanting solutions that reduce the amount of toxic chemicals. They don't want to be regulated with
Right.
these things. They want solutions, but also that it's safer for the worker and the person that is creating these products, even if it's a tiny little bit. That still has an impact not only on us and our environmental health and our human health, but also the natural world. So
Right.
it's really exciting. Thank you for clarifying a little bit or expanding upon that. When you were referencing, I got really excited that that's also part of this project. So let me just double check. We don't have any other questions.
Cool.
But one last thing before we go, do you have any just quick things? I know everyone's always looking for ways that they can help, and asking, what can I do to kind of move this along and help out? Do you have any just kind of quick pointers or things you want to end the show with, Chris?
Oh, geez. How they can help out
It's a
with
big
this.
question, yeah.
Well, beyond what I mentioned earlier, just like literally, like if you could just reach out, tell us anything, that would be helpful.
Okay.
And as far as this type of research or what the center works specifically,
Yeah.
I think just educating yourself and passing that along. I've been working with like this kind of stuff for a while, and like I just finally got in the habit of looking at my like apple core and being like, oh, this is compostable. I shouldn't throw this in the trash anymore.
Oh no!
And
Don't
then,
say
like-
that out loud.
Yeah.
And how long have you been at ESF? We won't.
I don't. There's things that are just
It's all
habits,
right.
and you have to like
Yes.
learn to break them.
Change those behaviors. Yep.
And like taking a closer look at my recycling, and I
Yep.
think those are things that you could do too, and saying
Right.
like, what's actually recyclable, what's not. I
Right.
know you had Jesse Cairns on
Yeah.
here
Yep.
talking about the problems with that. So like
Yep.
these are all related problems, and the core solution that's attainable for all of us is just education.
Okay, great. Well, thank you for that. That is our show for today. So I want to thank Chris Thomas. Again, Chris, thank you so much for joining us today, sharing your research and insights with us about biodegradable plastics. I love how I learn every time I'm on here, and I learn so much from you. So thank you. You can check previous episodes of ESF Connected. You can check ESF TV on YouTube. Make sure that you subscribe. For Chris Thomas and all of us at ESF TV, I'm Kate Walker. Thank you for joining us, and we'll see you next time.
Thank you.
Thank you.
Oh man.